Hello again. This is back in Calculus 3, and I am ready to start section 2.2. But actually, if you look in the textbook, 2.1 is about two-dimensional vectors, and 2.2 is about three-dimensional vectors. I am sort of treating both of those sections at the same time. So I will primarily focus on 2.2 in this lectures, in this series of lecture videos. But some of the stuff from 2.1 is also included. So you may want to look at 2.1 and 2.2 before you start on your homework for this chapter. Okay, so here we go. All right, so 2.2, actually both 2.1 and 2.2, list properties of vectors. And you don't really have to be able to list any of these. I think most of these are pretty much intuitive from what you learned in the past. These are listed in your book on page 112. All right, so for instance, you know that u plus v is equal to v plus u. In fact, we have technical names of these, algebraic names of these things. And so do you know what the property is called? U plus v is equal to v plus u. Yeah, because they commute, and this is called the commutative property. I didn't really know there was a T in the middle because everybody just used to call it commutative, and this T is almost silent, but commutative property is the proper name of this property. And then the second one, u plus v plus w is equal to u plus v plus w, right? So this is called the associative property. And by the way, I hope you are taking notes along. It may look silly that you're just watching video and taking notes, but as you engage in writing, your hands and your brain, your eyes are all coordinated. So you actually learn material. Sometimes mathematicians actually take notes as they read their mathematical proofs, because when you read somebody's proofs, they may not make much sense, but as you start writing, things suddenly start to make sense. And you say, oh yeah, now I can understand. So, all right, k times u plus v is equal to ku plus kv. Of course, here I am assuming k is a real number. What do we call this? Scalar multiplication, right? And so this is the property called the distributive property. And so we can, and there are more. In fact, there are a lot more on this list. I think the book lists 8 different properties for vectors. So this is called the distributive property. And so all of these are true for all vectors, actually not just in 2- and 3-dimensional spaces, but in all vectors, because there is a concept called vector spaces in more abstract linear algebra. And these are some of the properties that would define what a vector space is. All right, now, so fundamentally, okay, there are only 2 operations with vectors. Okay, I say fundamentally because there are a few more coming up specifically for R2 and R3 vectors. But one is called addition. You see that in property 1 and 2. And the other is scalar multiplication, right? These are the only 2 that are required to have in the vector space. And so make sure you don't do things like multiplication of 2 vectors. Okay, so this really doesn't make sense. Nobody really defines it. There is a dot product and there is a cross product, but not just a product of 2 vectors. We don't divide a vector by another vector. Okay, so this does not make sense. And of course, for the same reason, this does not make sense. So you don't divide a vector by a vector. Let's make sure that you don't write things like this. Okay, only 2 properties are defined. Now, subtraction is a operation, but remember, subtraction is basically an addition of a vector with the additive inverse or the negative of the second vector. So it is a part of addition that involves a scalar multiplication by 1. All right, So as you look at some of these exercise problems assigned to you, you will see that you will have to do some calculation, trigonometric calculations. All right, so here's an example. Let's say you have u and v. These are two vectors. One has, the first one, u has length 45. Second one has length 52. And suppose that we are given that these two vectors are apart by the angle of 25 degrees. All right. So find u plus v. Okay, so how do I do that? Well, actually, I think the question was more like find the length of u plus v, the magnitude of u plus v. All right. And of course, you don't have to have this exact same picture. Okay, and there is a more of a abstract way of showing this, doing this problem, but it helps to draw a picture. Okay, so the original question basically says that u has length 45 and v has length 52, and they are 25 degrees apart. Find the length of the sum. Okay, so how do you do that? Well, it's probably helpful to write down what u and v are. Okay, now u is clearly 45, 0. Okay, the way I drew this, I drew u to go in the positive x direction. So this is clearly that. Now v is a little more tricky, little trickier to write, but that's okay, right? Because we know how, using trigonometry, you know what the x and y coordinates of v are. All right, so the first one, the x coordinate is 52, that's the length, times the cosine of the angle 25. Remember, cosine is the adjacent, which is the x-axis. And then the y coordinate is 52 times the sine of 25 degrees. So then u plus v, from here, I mean, this will be a pretty easy question. You may want to just pause the video and try to finish this on your own, and then come back and make sure you get the right answer. That's a great thing about watching a lesson on video as opposed to being in the classroom, because you can't just pause me if I were lecturing in the classroom. That would be nice from your standpoint. I would not like to be paused by a student clicking on something. But anyway, so what is u plus v? Well, you ask you ask and you add the two x coordinates together. The new x coordinate is 45 plus 52 cosine 25. And you can just calculate that. And second coordinate is, of course, 52 sine of 25 degrees. Easy stuff, right? And then you can go ahead and evaluate this. Now, you can use your scientific calculator. You can use an app on your phone. I don't care how you get this, but you should be able to, just use some app, or even your operating system on your PC may have a scientific calculator. By the way, I should also mention, I have a couple of apps that I can suggest here. All right, so when you do the calculation, you will see, make sure your calculator is on the degree mode, and this will be 92.13. The second coordinate is 21.98. I am not picky about how many decimal places you keep, but these are approximate numbers. Maybe just to make sure these are approximate numbers, I will do a wavy line here. All right, so what is the correct answer for the magnitude of the sum? Well, you just use that formula, and that involves a very long square root sign. And then you do 92.13 square plus 21.98 square. And that should give you the answer. All right, what is the answer? It turns out to be about 94.7. And you can see, of course, this is very practical, and you can probably imagine many applications of something like this. When you have two forces acting on a point, or when you have an airplane flying and the wind blowing and so on, you often have to find the sum, which in physics is called the resulting force, right? All right, now, in R2, remember what that is? Yeah, it's called the plane. It's such a plain name for that. But the plane, of course, you only have the X and Y axes. And so you have four quadrants, okay? Quadrant 1, quadrant 2, 3, and 4. Okay, so in R3, things get a little more complicated. How many quadrants do you have? Well, you have 4 on the top and 4 on the bottom, right? So you have, what do we call them? You don't call these 8 quadrants because quad means 4. And so what, 8 what? Octant. Or octants would be the correct name. All right, now it's really hard to draw these things, so I'm not gonna even tell them. But basically the first octant, maybe I should just say, the first, as in English, the first octant is where X is positive, Y is positive, and Z is positive. The other octants you don't have to worry about. I mean, basically it goes the same way, 2, 3, and 4 on the top counterclockwise, and 5, 6, 7, 8 are in the bottom half, again, counting counterclockwise. But what I do want you to be able to figure out is how to describe a set of points in 3D, okay? So for instance, what if I write this equation, x squared plus z squared is equal to 4. Oh, maybe it's a bit too hard for the beginning one, okay? You know what the equations mean, I hope, right? When you say an equation of a geometric object, what that means is that the point is on that geometric object, whether it's a sphere or a plane or parabola or something. The point is on the collection of sets, the graph, if and only if it satisfies the equation. And so we have to come up with a set of all points in 3D that is satisfied by this, or that would satisfy this equation. All right, so what kind of points are they? Well, x squared plus z squared is equal to 4. Notice here, y is missing. Right? And so y is independent. Y can be anything you want, but x and z are constrained or bound by this rule, x squared plus z squared is equal to 4. So for instance, when y is equal to 0, well, what does that mean? Well, y is equal to 0, I mean this plane here, okay? And I like to draw a little a flat sheet of paper like this. I call this the canvas, all right? Not the one we use in computer, but a canvas like the piece of paper or the piece of cloth that you draw or sketch on, right? And so this is x, y, z. So what I have just drawn is basically the plane, y is equal to 0. And on there, you can draw x squared plus y squared is equal to 4. And that, of course, is going to be a circle, right? Of radius what? Radius 2. Okay, so it goes through 2, 0, 0 and 0, 0, 2. And because y doesn't appear, it is independent. And so the answer to this question is basically a horizontal cylinder. Okay. And so you should be able to sketch a graph described or expressed by an equation and vice versa. If I have a simple graph or a plane or something, you should be able to sketch that as well. All right, so let's try another one here, okay? Why don't you try to do x is greater than 2, greater than or equal to 2. Okay. Oh, by the way, this is a horizontal cylinder, the first one. And then let's do the set of all x, y, z such that y squared minus z is equal to 0 or something like this. All right. And so it's slowly appearing on my computer screen because again, there's a lag time when I sketch or write on this tablet. But anyway, you have 2 questions here. Okay. x is greater than or equal to 2, and then x, y, z such that y squared minus z is equal to 0. See if you can draw these pictures, okay? And maybe you can pause this recording right now and then come back when you think you have drawn the correct picture.